final aspect of the memory model is retrieval. How do we access these memories, and what is it that we are actually retrieving? And this is a little bit tricky. We should not think about memories as stored files that we can pull out and review in crystal clear detail, but rather as reactivation of neural pathways throughout the brain. Activation of these neural pathways is what causes the visual, auditory, or other sensory sensations that are memories. These sensory recollections are not complete, and therefore we fill in the gaps with what we think should have happened. Therefore, every time we access or activate those neural pathways, we both strengthen and change them. Since our brains are slightly different now than when we laid down the memories originally, we remember things slightly differently every time. Even more confusingly, since we cannot reset our brains to how they were when the memory was first created, we cannot be consciously aware of the precise ways in which the memories have changed. We cannot say, for example, well, I used to remember my first bike as being blue, but now I remember it as being silver. So here again is a representation of the information processing model of memory, with sensory stimulus as the input, which resides very briefly in sensory memory, some of which passes through to short-term memory or working memory. Some or all of that information is encoded into long-term memory for later retrieval. That which is retrieved, accurately or not, is processed in the conscious mind, therefore in working memory, and used for output. For example, recalling the names of the presidents in order. We must also keep in mind that context matters. We will recall information more accurately in the same environment in which it was first learned. Similarly, we will remember things better when in the same mood in which we learned it. This is called state-dependent memory. It is also important to note that some moods are better than others for recall and encoding. Generally speaking, stress reduces learning and recall. Therefore, it is best to learn when calm and relaxed, and recall when calm and relaxed. All of this calls into question the accuracy of eyewitness testimony. If two people witness the same accident, for example, they may give two completely different accounts of what happened. Elizabeth Loftus proved this in her research. Simply changing how a question is asked changes the witness's answer. If asked how fast the cars were going when they smashed into each other, witnesses estimate much higher than the group that was asked how fast the cars were going when they hit each other. Children are especially prone to false memories, and this is an area of great debate and concern in the psychological world. It can sometimes be very difficult to determine whether a person's recollection of childhood abuse is accurate or a false memory generated during or after childhood. And certainly, certainty is no indicator of accuracy. There is no correlation between how certain a witness is of an event and the accuracy of that person's recall. And so we also have to talk about forgetting and what happens when we forget or lose memories. We have several theories, the first of which is Decay Theory, which argues that forgetting is simply caused by the passage of time. In this case, we're suggesting that neural pathways whose activation produces the sensation of memory has decayed and is no longer intact. This appears to be what is happening in Alzheimer's disease, where abnormally folded tau proteins cause a breakdown in the membrane of the neuron's axon. The neurons slowly fall apart, preventing activation of associated networks, thereby destroying the memories themselves. Some similar mechanism may account for normal forgetting, but such a mechanism has yet to be identified. Normal forgetting, that is forgetting not accounted for by disease or dementia, may simply be a case of use it or lose it. In an attempt to maintain efficiency, the brain trims away unused synaptic connections. Sometimes needed connections are inadvertently trimmed in the process. Another theory is the interference theory. Interference theory and decay theory are not necessarily mutually exclusive. Both may be accurate and happening at the same time. Decay theory is a storage error theory, whereas interference theory is a retrieval error theory. Interference theory argues for two processes: proactive interference, where previous learning decreases your ability to remember more recently learned material, and retroactive interference, which is the opposite. You cannot remember older material because of the recently learned new stuff. In proactive interference, you may find it hard to learn Spanish because you had previously learned French very well. In retroactive interference, your newly learned Spanish inhibits your recollection of the previously learned French. A third, less widely accepted theory of forgetting is Freud's repression theory. Freud argued that painful memories are repressed into the unconscious and not available for conscious retrieval without the aid of psychotherapy. The memories are still there, they're in the unconscious mind, and they affect behavior. This theory became so widely accepted that it was for a time psychological lore, but increasingly the theory has lost ground. There is little evidence that painful memories are repressed, and research suggests that the more emotional a memory, the more likely it is to be recalled. Certainly, many soldiers returning from war or people who are victims of abuse would be happy to repress traumatic memories, but cannot due to the emotional nature of the event. So finally, we have to talk about the biology of memory. What precisely are memories? Where in the brain are they? We know that the cerebellum is very important in the creation and retrieval of implicit memories. We know this because people who have had extensive damage to the cerebellum have a lot of difficulty learning to improve in things they already know how to do, which is a process of the implicit memory. And we know that the hippocampus is important in the encoding and retrieval of explicit memories. And yet we also know that some memories can still be accessed even in patients with damage to the hippocampus. Our best explanation so far is in what we call long-term potentiation, or LTP. In a nutshell, LTP is a persistent strengthening of synaptic connections between two neurons as a result of repeated use. This increased sensitivity and strength through usage increases the chances, or potential, that the signal message will get through to the neural network efficiently and accurately. The more connections and the stronger the connections, the better the learning. The best way to enhance LTP is through learning followed by adequate sleep. It appears that a great deal of long-term potentiation occurs during the sleep cycle. Okay, so that is our overview of the memory process. The next step is to take the brief quiz that is based on this lecture.